Few forces in nature command our attention like lightning. It manifests itself into the dramatic and beautiful, a fleeting burst of energy that lights up the heavens, and reminds us of the sheer power coursing through our planet. What if we could harness the raw power of nature's fury to power an entire town? Could this electrifying dream become a reality? Join us as we explore the science, the challenges, and the possibilities of turning one of nature's most awe-inspiring displays into a source of energy. Lightning is one of nature's most electrifying displays, but have you ever wondered how it forms? And just how much energy it carries? Let's dive into the fascinating science of lightning. It all starts with a thunderstorm. Inside the storm cloud, water droplets, ice, and air currents are constantly moving. This motion separates electric charges. Positive charges gather at the top, and negative charges build up at the bottom of the cloud. This creates a huge electrical difference between the cloud and the ground, which is mostly positively charged. When this difference becomes too big, the air between the cloud and the ground can't hold it anymore. A giant spark, called lightning, jumps from the cloud to the ground. Did you know that a single lightning bolt can produce up to 1.21 gigawatts of power? That's more than 1,000 kilowatts unleashed in the blink of an eye. To put that into perspective, the average American household consumes about 30 kilowatt hours of energy per day. That means just one lightning bolt could theoretically power hundreds of homes for a full day. With 1.4 billion lightning flashes per year, or about 44 flashes every second, it seems like we've got the ultimate renewable energy source right in front of us. The global energy crisis. Solved. How come no one thought of this before? Well, there's a reason why we haven't done it yet. The challenge is enormous. Unfortunately, relying on lightning bolts to power our ovens, TVs, and refrigerators would be far from cost-effective. The problem is that the energy in lightning is contained in a very short period of time, only a few microseconds. Absorbing lightning and converting it into useful energy might sound like an electrifying idea, but in reality, it's an extraordinary challenge. To make it work, we'd need complex capture systems, advanced storage facilities, and a way to safely distribute the energy. According to the National Oceanic and Atmospheric Administration, lightning strikes somewhere on the Earth approximately 44 times every second, but most of those strikes occur in the tropics and remote mountain regions. Constructing a state-of-the-art energy conversion and storage facility in such conditions would be enormously difficult. Distributing that energy to more populous areas would add even more logistic and economic challenges. It's unlikely these systems would ever yield enough energy to justify their enormous cost. Lightning, a dazzling display of nature's raw power. But how much is that power actually worth? Let's break it down. A typical lightning strike contains about 1.2 gigawatts of power, an enormous burst of power. But here's the catch. That power is released in a split second, so the total energy amounts to just 1/4 of a kilowatt hour. To put that into perspective, the average household consumes around 30 kilowatt hours of electricity every day. A single lightning strike wouldn't even power your home for an hour. And what about the cost? Most Americans pay about 20 cents per kilowatt hour for electricity. That means the energy from a lightning bolt would only be worth about 5 cents, just a nickel. So while lightning is powerful, its energy isn't particularly valuable in economic terms. Fascinated by the power of nature? Want to explore more science? Don't miss out. Hit subscribe now and join us for more incredible stories that spark your curiosity.